Now in this video, let us take a look at very important and indeed a very popular interview dynamic programming problem, that is called as the edit distance. Now the thought process used in this problem, just a disclaimer alert, is very similar to the thought process that we used in the longest common subsequence problem. So I would recommend to solve that first and understand that properly. And then going through this problem, the solution should be a piece of cake. So with that being said, let's begin. We are given a couple of strings, S1 and S2. Our job is to make these strings equal to each other. How can we do that? With minimum number of operations. Now what is an operation? We can either insert a character, delete a character, or replace a character. And these operations are only allowed on the string 1, this string. Let's take one example to understand everything properly. Here, the string 1 is Goldens, the string 2 is Glides. Let's see one possible way using these operations on the string 1 to make them equal. We can just ignore G, it is already equal. This O, we can replace it with L. This L, we can replace with I. We can leave D as is. We can leave E as is. We can delete this N. And the string would then become equal to S2. So Glides, Glides. Now how many operations we did here? We did 4 operations. Now this is not just the only way. Perhaps we can, let's say, delete O. We can then insert I between L and D. And then we can just delete N. So this would also make it Glides, which would be equal to this. How many operations we did here? Similarly, there might be other ways. Our goal is to find that way which involves minimum number of operations. So let's try to solve this problem by hand. I have written the recurrence relation that we have derived in the last slide. This is the case when the characters are matching. This is the case when the characters do not match. Here is the string 1 and here is the string 2. Also, I have appended both of these strings by an empty string. Again, they are just empty strings and they shouldn't change our string 1 and string 2. But they will make our calculation very easy. You will see how. Now one more thing. Whenever we want to calculate the answer for any ij, we can be dependent on I plus 1 j plus 1 based on this equation, or we can be dependent on I plus 1 j, or we can be dependent on I and j plus 1. So we will try to fill from the bottom to the top and then from right to left, so that we have answer to our sub problems first before we get the answer to our main problem. So let's begin. First, when both of these strings are empty string, this case. Now in this case, we actually do not need to do anything. The strings are equal naturally since they both are empty strings. So we just put 0 here. Let's first fill this particular row. This represents when S1 is going from the very last index, which is the empty string. So basically this represents an empty string for S1. If you want to fill this particular entry here, what it means? It means the array distance for this empty string and for this substring of S2 that is going from S till the end. Now in this case, we would have to delete S in order to make these strings equal. So the answer would be 1 here, or one operation. Similarly here, again we have this as an empty string and then 2 characters here in string 2, the substring of the string 2 that is going from E till the end. And the only option to make them equal to this empty string is to delete these characters. So effectively I'll put 2 here. Similarly, it's very easy to see that this should be 3, 4, 5 and 6. By similar logic, we can fill this column, which now represents S2 being the empty string and S1 being the strings from S till the end, from N till the end, E till the end, and so on for these individual entries. Now if you want to fill this, what does this mean? S2 is an empty string, S1 is the string or the substring precisely going from S till the end. So in order to make this equal to this empty string, we would have to delete S. That is the least number of operation that we have to do. So it should be 1. So let me put 1 here. Oops. Similarly, here it means an empty string and then 2 characters. So we have to delete these 2 characters anyway to make these strings equal to each other. Those are indeed the least number of operations. So I put 2 here. It's easy to see that this should follow naturally. 3, 4, 5, 6, 7. Now let's try to fill our remaining part. Let's proceed as discussed from the bottom to top, and in every particular row, let's move from the right to the left. Let's take a look at this case first. Here, this means the string S2, which is going from S till the end, or this particular substring of S2 and this particular substring of S2. Now for ij, basically I is this and j is this. Let's first see which is the case. Is it this one or this one? Now you can see that the characters match here, and therefore it's this case. What is the answer in this case? It is the answer to I plus 1 j plus 1. So it is this, which is also something that we can see because both of these are equal to each other. So we put 0. Let's move here. Let's take a look at the I and j characters. Are they equal? No, they are not equal. So it is this case. What is the answer in this case? It is the minimum of I plus 1 j plus 1, I plus 1 j, and I and j plus 1, and then we add 1. So the minimum of these 3, which is 0, and then we add 1. So it becomes 1. Let's move to this. The I and j characters S and D do not match. So again, by the same logic, we take the minimum of these and then add 1. It should be 2. Here, the characters again don't match. Take the minimum and add 1, which is 3. 2 plus 1. Here, characters again don't match. So we take the minimum and add 1. So it should be 4. Here the characters don't match S and G. Take the minimum and add 1. So let's put 5 here. Now let's move to the next row, which is this, and try to fill from right to left. What is the answer to this? First, do the characters match? No, they don't. So take the minimum and then add 1. So it should be 1. Here the characters again don't match. So take the minimum and add 1. So it should be 1. Characters don't match, T and N. So take the minimum and add 1. So it should be 2. I and N, the characters don't match. So let me put 3. Characters don't match, L and N. So let me put 4. The characters G and N don't match. So let me put 5. Let's move to our next row. S and E, the characters don't match. So let me put 2, which is 1 plus 1, the minimum. E and E this time. Here, E and E, they match. So we put the answer to I plus 1, J plus 1. So let us put 1 here. And you can also verify alongside. So for example, this and this case has answer 1, which makes sense because we just, in order to make them equal, we just have to delete this n. It is the least number of operations, which is 1. So let's move here. Now let's move to this one. Here the characters don't match, D and E. So let's take minimum and add 1, which is 2. Here the characters don't match, so take the minimum and add 1, should be 3. The characters don't match, so we take the minimum, add 1, which should be 3 plus 1, 4. The characters don't match here, so take the minimum and add 1, so it should be 5. Let's move to this layer. Here the characters do not match, so take the minimum and add 1, so it should be 3. Here the characters don't match, take the minimum, add 1, it should be 2. Here the characters match, so the answer is this one, I plus 1, J plus 1, so we put 1 here. Here the characters don't match, so we take the minimum here and add 1, which should be 2. Here the characters don't match, so take the minimum and add 1, it should be 3. Here the characters do not match again, so take the minimum and add 1, so it should be 4. Let's move to this layer. Characters don't match, take the minimum, add 1, so let's put 4 here. Here the characters this time again do not match, this is E and this is L, so we take the minimum and add 1, so it should be 3. The characters do not match, take the minimum and add 1, so it becomes 2. Characters do not match, so it becomes 2. Here the characters do match, it is L and this is L, so this is our answer. Let us put 2 here. The characters do not match, so let us put the minimum at plus 1, so it should be 3. Let's move to our second last layer, or the second layer rather. Here the characters again do not match, so minimum plus 1, which is 5. Here the characters do not match, so minimum plus 1, which is 4. Characters do not match, so minimum plus 1, which is 3. Here characters do not match again, so minimum plus 1, which is 3. Again they do not match, L and O, so minimum plus 1, which is 3. The characters G and O do not match, so minimum plus 1, let's put 3, which is 2 plus 1. Let's move to our last layer. S, G, the characters do not match, so let's put 5 plus 1, which is 6. E and G do not match, so let us put 5, which is 4 plus 1. D and G do not match, so let us put 4, which is 3 plus 1. I and G do not match, so let us put 4, which is 3 plus 1. L and G do not match, let's put 3 plus 1, which is 4. G and G do match, so let's put this, which is 3. Eventually, our answer for the complete string S1 and the complete string S2. By complete, I mean going from 0 till the end and 0 till the end. So overall answer would be ED of 0, 0. And therefore, the answer is 3. So let's look at the complexity of the approach that we have discussed. Let's first take a look at the time complexity. Now in our approach, we have filled all of these entries of the matrix. Let me call the size of S1 to be maybe M, and size of S2, let's say it's N. Then we have basically filled M cross N entries. And what is the time that we took to fill each individual entry? It is constant. Why? Because the answers to our sub-problems were already computed before, and we just plugged in their values whenever we try to fill in any entry. And this is actually because we tried to fill this matrix from the bottom to top and from right to left. So we followed the right ordering when we were actually filling this DB matrix. So effectively, coming back to our time complexity, what is that? It would be order Mn and order 1, which is basically order Mn. Space complexity is again very straightforward to see. We just have a matrix, extra matrix constructed. What is the size of the matrix? It's order Mn. So this is both the time and the space complexity. M and N are the length of the strings. Now let's take a look at the intuition for this problem. The intuition for this problem is again very similar to the longest common subsequence problem. So I would encourage to revisit that again to fully understand, and then going through this thought process should be very easy to follow. So let's begin. Overall, when we look at the string 1 and string 2, let's say string 1 is C1, C2 till Cn, and string 2 is C1 dash, C2 dash till Cn dash. Now overall, when we look at these two strings, there are only two possible things. Either C1 is equal to C1 dash, or C1 is not equal to C1 dash. Basically, either the first characters match of first characters, or they don't match, right? In the given example strings, for instance, the first characters match. But we could also have an input where the first characters don't match. For example, if this G in S1 would have been X, then our first characters won't be matching. Now let's first zoom into the case where the first characters were matching. Let's see how we should think about it and how we should approach the problem. Now it's very easy to see that if the first characters of both the strings are matching or they are equal to each other, then actually there is no need to do anything or any operation. Because these characters, since they are already equal to each other, they are not causing any mismatches. So we don't need to do any operation at all. So we keep them put just as is. And then what remains? This particular parts. So string 1, that is going from the index 1 till the end, and the string 2 going from the index 1 till the end. So basically, the answer that we have to find for the overall string is nothing but the answer to this particular part, because the first characters are already equal to each other, so we can just put them as is. Mathematically, if I describe edit distance, let me call it ED, of the string 1 and string 2, something that we have to find in this question, would be equal to the edit distance of the string 1 going from index 1 till the end, and of the string 2 going from index 1 till the end. Now this S1 is also basically the string 1 going from 0 till the end, and this is also going from 0 till the end. So I can just to simplify this equation, let me get rid of the end parts because it's clear in itself. So I can say ED of 0 0 is equal to ED of 1 1. In fact, if you generically think about it, let's say we want to find the edit distance for any string that is going from I till the index end, and for any string S2 that is going from the index J till the end. For example, if this is I and this is J here. Now if C3 is equal to C3 dash, this equation should hold true. So we can say that ED of IJ, when the character of the string 1 at I is equal to the character of string 2 at J. If this is true, then EDIJ is equal to ED I plus 1 and J plus 1. So generically we can say that for any string S1 that is going from the index I till the end, and for any string S2 that is going from the index J till the end, we can say that ED IJ is equal to ED of I plus 1 and J plus 1 when the character of the string 1 at I is equal to the character of the string 2 at J. Now let's take a look at the case 2. When the character 1 of both the strings, the first character, they don't match. Now in this case, if there is a mismatch, what can we do to make the strings equal to each other? Now according to the problem, there are only 3 things that we can do on the string 1. We could delete the character, we could insert a character, and we could replace a character. Now let's see these cases one by one and see how our solution unfolds in these 3 cases. Now let's take a look at the case 1 where we delete a character. Let's take one example. Maybe we have the string 1 as, let's say, ABC and the string 2 as PQR. Now, the first characters are not matching and we have opted for deleting the character from the string 1. So we delete the character, the first character A. So what remains? The string 1 from index 1 till the end and the string 2 from index 0 till the end. So overall, our answer would be 1 for the operation deletion where we deleted the character A, plus the answer to the remaining part, which is the string 1 from index 1 till the end and the string 2 from index 0 till the end. So mathematically, I can say that in this case, the array distance of the strings would be equal to 1 plus array distance of the string 1 from index 1 till the end and the string 2 from index 0 till the end. Again, same as here, this is generically valid for any INJ. Now the second case, when we insert a character in the string 1. Now when we insert a character, first of all, we will only insert a matching character of the string 2 because we want to make the string 1 and string 2 equal to each other. So if the first character of the string do not match and we have opted for inserting the character, we will insert the matching character of string 2, which is P, at this place. So my first string would become PABC and the second string would be PQR. Now after insertion, these characters are now matching P and P. Now what remains? This part and this part. Now what is this part? Mathematically, it is the string 1 that is going from the index 0 because we have inserted P prior to A. So this is index 0 till the end, but string 2 is now indexed from 1 till the end. So mathematically, I can say that array distance of my strings here, when we have opted for insertion, is equal to 1. 1 is for insertion plus my answer to array distance of 0 and 1. This is for string 2 and this is for string 1. Now the third and the final case is when we replace the character of the string 1. Again, let's understand with this example. Now the first characters are not matching, A here and P here, and we have opted for replacing the character of the string 1. So we just replace this A by P. After this replacement, the first characters are matching. Now what part remains? This and this. What are these mathematically? String 1 from index 1 till the end, string 2 from index 1 till the end. So I can say that array distance of string 1 and string 2 completely, 0 till the end and 0 till the end, would be equal to 1 for replacement of the first character of the string 1 plus array distance string 1 from index 1 till the end and string 2 from index 1 till the end. Now these are also valid generically for any ing like this that we have discussed. So in a nutshell, when the characters mismatch, there are only three things that we can do, three operations as per the question: delete character, insert character and replace character for the string 1. Now since we want to find the least or the minimum number of operations, therefore it makes sense to take the minimum of these three possibilities for our optimal minimal answer. So essentially what I am saying is that ed00 should be equal to minimum of 1 plus ed10, 1 plus ed01 and 1 plus ed11. Basically I can take 1 as common, so my equation becomes minimum of ed01, ed10 and ed11 plus 1. So we take the minimum of these three and then add 1. So this is the equation that we use when the characters mismatch, and this is the equation we use when the characters match. Generically they are valid for ing, this one as well as this one. Let's try to implement the approach that we have discussed. I have created a function called as the calculate array distance. It takes in the input of two strings and returns the answer. I have taken the two strings the same that we were using in the examples. Ultimately, I just print these two strings for cross-checking. First, let me try to grab the length of the individual strings so that I can use them conveniently later. Let me call them length 1 and length 2 to be the lengths of string s1 and s2 respectively. Next, let me create the DP data structure. Let me call it ED, the same as we were doing in the examples. So that should be equal to the number of rows should be equal to length 1 plus 1 and the number of columns should be length 2 plus 1. I am using plus 1 to signal or to take into account the empty string. Next, let us try to fill our base case. Now, when there are empty strings for S1 as well as S2, which is basically ED of length 1 and length 2, we just put 0 because we don't need to do any extra operation here. Next, let's fill our base case for the bottommost layer, the layer in which the string 1 is empty. So if the string 1 is empty, we just have to delete all the characters of the string 2 to make them equal. So let me try to write a for loop. Effectively what I am doing in for loop is pretty much the same that we saw in the example. I'm trying to fill it from right to the left. I'm trying to fill the bottommost row, which is basically ed length 1. And then I'm adding the rightmost or the next or the immediate right answer plus 1. Plus 1 is to delete this character that I'm looking at, which is basically the J. And then this is my answer that I've already computed. So you might recall the bottommost layer when we were doing the example, we filled from 1, 2, 3 and till the length of the string 2. So this is pretty much doing the same thing. Effectively, just to summarize, I wrote a comment. When the string 1 is empty string, there is only one choice to make in order to make the two strings equal. And what is that? To delete all the characters of S2. So therefore, this will fill from 1, 2, 3, 4 from right to left. By similar logic, let's fill the rightmost column. It's pretty much the same as this, but the only difference here is here S2 is an empty string. So there is only one choice to make, and that is to delete all the characters of S1. So I've done pretty much the same here. I've moved from the bottom to the top and I've filled the rightmost column, which is length 2. Now let's try to fill the values for our remaining matrix using the recurrence relation that we have derived. So basically I can say that for int I is equal to length 1 minus 1, length 2 minus 1, now there are only two possibilities. The length, or rather the characters at the index ing match or they don't. Let's say they are matching. If they match, my answer should be equal to I plus j. My answer should be equal to I plus 1 and j plus 1. In this case, my answer, when they are not matching, when the characters do not match, it should be equal to 1 plus minimum of edi plus 1j edi plus 1j plus 1 and edi j plus 1, all the three values. Ultimately, we just return ed00 as our answer. Now let's try to run this and see what is the answer that it gives us. It is 3.